Welcome, dear students. I'm back. I'm Dr. Ajay Semalti from HNB Garhwal University, Srinagar, Garhwal. Welcome you again in our series of lecture on novel drug delivery systems. Today, in this lecture, we will be discussing mucoadhesive drug delivery systems. This is the first part of the lecture of mucoadhesive drug delivery system. We will be discussing this topic in the two lectures. So let's start up our discussion on the mucoadhesive drug delivery systems. After completing this lecture, you will be able to enumerate the mucoadhesive drug delivery systems, identify and learn the advantages and the basic principle of mucoadhesive drug delivery. We will be covering this lecture under the heads definition and concept of mucoadhesive drug delivery and systems, theories of mucoadhesion and factors affecting mucoadhesion. Dear students, if you want to define the MDDs, mucoadhesive drug delivery systems, the drug delivery systems which utilize the property of adhesion between mucin and mucoadhesive polymers for site-specific or systemic delivery with significantly prolonged residence time is called mucoadhesive drug delivery system. The transmucosal delivery of therapeutic agent is a popular method because membranes are relatively permeable, allowing for the rapid uptake of a drug into the systemic circulation and avoiding the first pass metabolism. The efficient uptake offers several benefits over other methods of delivery and allows drug to circumvent some of the body's natural defense mechanisms. The market share of transmucosal drug delivery system is enormous. If you take the example of year 2000 only, it was US dollar 179 million. It was the US market share only. Okay. So you can imagine that how much big this market of mucoadhesive drug delivery system is. Let's discuss the advantages. As we have little bit introduced this thing that it is useful for site specific or the local delivery of drugs or the systemic delivery of the drug. It can circumvent the hepatic first pass metabolism or other first pass. Increased contact time permits the localization and then improves the residence time of the drug. It enhances the bioavailability of those drugs that have bioavailability problem. It also inhibits the metabolizing enzyme in a localized area, and it can improve the stability of drugs. The drugs which are degraded in the GIT or other parts can be easily given through the transmucosal routes and can also mask the bitter taste of the drug. As far as the limitations are concerned, the mucin turnover is a problem. It affects the drug release. There is a low flux of drug. Per unit of time, you can say the drug passing through the membrane will be quite less. Enzymatic degradation of drugs may be possible in some cases, and the low residence time of systems, because many times when the mucoadhesive drug systems are placed in the bioadhesive in the some biological membrane, the dislodging may be there. Mucus, the mucus layer, it is a mucus is a translucent and viscid secretion, forms a thin continuous gel lining with mean thickness ranging from 50 to 450 microns in human to the mucosal epithelial surface. So it's just a lining, internal lining, the internal coating. Basically it's a protective layer. What is the primary function of mucus layer? It has got the protection, barrier, adhesion and lubrication function. Protection, it results particularly from its hydrophobicity. It is hydrophobic in nature. That's why it protects the body organs. Barrier system. It acts as a barrier in tissue absorption of drugs and other substrates. As far as the adhesion function is concerned, the mucous layer has the strong cohesion properties, and it firmly binds to the epithelial cell surface as continuous gel layer. Lubrication function refers to the continuous secretion of mucus from the goblet cells is necessary to compensate for the removal of the mucous layer due to the digestion, bacterial degradation and solubilization of mucin molecules. So mucus layer is a natural protective barrier and adhesive and lubrication function it is providing to the body. Mucus layer of the intestine is supported by the cellular layers of the gut wall. This layer consists of epithelium, lamina propria and muscularis mucosa. These tissues and mucus layers are collectively known as mucosa. Each epithelial cell is blanketed with a coating of microvilli as its apical surface known as the brush border. Mucus is secreted by the goblet cells, as we know. These are lining the epithelia or by the spatial exocrine glands with mucous cells acini. Drugs and other molecules must first pass the barriers of the mucous layer, brush border and the epithelial before reaching to the capillaries of lamina propria. However, the exact composition of the mucous layer varies significantly depending on the species, depending on the anatomical locations and the pathophysiological state of the species. Mucoadhesion is a complex phenomenon. It depends on the properties of polymer, biological tissues and the surrounding environment and many factors which we are going to discuss soon. It is recognized that every theoretical development has distinct limitation and that the operative mechanism probably involves a combination of several of these processes. The most commonly quoted explanation involving surface energy, thermodynamics and interpenetration theory. So we will be discussing the theories also. Basically, when a biological substrate is being attached with the polymeric substrate, it is called bioadhesion, mucoadhesion. Okay, so bioadhesion and mucoadhesion are both same thing. Now let us discuss theories of mucoadhesion. The mucoadhesion has been explained by various theories like electronic theory, absorption theory, wetting theory, diffusional theory, mechanical theory and fracture theory. So please remember these 6 names. These are very important. Okay, 6 theories of mucoadhesion. So we'll be taking up one by one. Like electronic theory. So I have made a tabular presentation for you for making it easy to reproduce or represent or represent in the examinations. Just electronic theory, what is the mechanism? Electron transfer occurs upon contact of adhering surface due to differences in their electronic structure. An electrical double layer is formed as the interface with the subsequent adhesion due to attractive forces. While in the adsorption theory, there is an attachment of adhesive is occurring there and due to hydrogen bonding and the van der Waals forces resulting in the chemical bonding. So weak van der Waals forces and the hydrogen bonding brings about this adsorption basically, and interaction across the interface occurs as a result of strong covalent bonding. Wetting theory, as the name suggests, mucoadhesive polymers in liquid systems spread spontaneously and develop intimate contact with mucous membrane. Spreading coefficient that SAB should be positive. So SAB is equal to YB minus YA minus YAB. Here Y is the surface tension energy of the liquid A and YB for liquid B. Surface energy of the solid B, that is the substrate, and YAB is the interfacial energy between the solid and the liquid. So we can explain it with this equation simple. In the diffusion theory, as the name suggests, the diffusion is occurring, concentration gradient is there, concentration gradient governed interdiffusion of flexible polymer chain across an adhesive interface occurs. Interdiffusion, this interdiffusion depends on similarity of solubility parameters. Available molecules, molecular chain length and their mobilities and diffusion coefficient plus the time of contact. These are the various factors which govern this diffusional attachment, you can say. Mechanical theory says that as per the mechanical theory, the adhesion arises from an interlocking of a liquid adhesive on setting into irregularities on its rough surface. So it is a entanglement basically. So rough surface provides an increased surface area available for interaction along with an enhanced viscoelastic and plastic dissemination of energy during the joint failure. In the fracture theory, it analyzes the adhesive strength to the forces required for the detachment of the two polymers of the two involved surfaces after the adhesion. So the two involved surfaces after the adhesion uh, are basically responsible. The force behind them, the adhesive strength to the force required for the detachment of the two involved surfaces after adhesion is fracture theory's base. How we can fracture basically the two, how we can fracture them apart. For studying the mucoadhesion of non-flexible polymeric chain bearing polymers, we can give this fracture theory. Now, process of mucoadhesion, if we say in general, it has got the two steps basically. In step 1, contact stage is there. Step 2 is the consolidation stage. In this contact stage, this is the first stage, there is an intimate contact either by the swelling or wetting. It occurs between the mucoadhesive surface and the mucoadhesive and mucous membrane, mucoadhesive system and the mucous membrane. While in the step 2, in the consolidation stage, various physicochemical interaction occurs due to consolidation and strengthen the adhesive joint, leading to the prolonged adhesion. So the interaction include interpenetration between the polymer chains and the mucosal membrane. The formation of chemical bonds between the entangled chain is responsible for them. So in some cases, in some text also, stage 3 is given by the increased resistance time or increased entanglement or the development of force. So either you can express them in this 2 step or in the 3 steps, but the gross scenario is the contact stage and the consolidation stage. Okay. Now let us discuss the very crucial factors which affect the mucoadhesion. There are the factors, we can divide them in the 5 major categories: polymeric factors, environmental factors, physiological factors, drug related factors and biopharmaceutical factors. Now let's take them one by one. In the polymer related factor, first factor is molecular weight. We have discussed it a little bit in polymers also, that how we develop, how we select the mucoadhesive polymer. Higher the molecular weight, higher is the mucoadhesion. Optimum molecular weight ranges from is 10 to the power 4 Dalton to 4 into 10 to the power 6 Dalton. Large molecular weight polymers will not hydrate readily to free the binding groups to interact with a substrate. So it is not like that you can take a very high molecular weight polymer. There is a ceiling. Okay, optimum molecular weight is required. However, the low molecular weight polymers will form weak gels and readily dissolve. So you can't take too light or too heavy polymer. Okay. In the polymer related factors, hydrogen bonding capacity is another factor. Polymers must have the functional groups that are able to form hydrogen bonds, because they are basically the consolidating, they are governing the consolidating stage. They are coming together, but the consolidating stage is governed by the formation of bonds. Okay. So the polymer chain length is the second factor, that polymer molecule must have an adequate optimum length. That's why then only the entanglement is possible. Spatial conformation, the helical conformation may shield the adhesive active group. So the helical configuration may distort or may adversely affect this mucoadhesive effect. Polymer chain flexibility is another parameter, and cross-link density. It is important for interpenetration and entanglement, allowing binding groups to come together. Because for entanglement, the polymer chain must be flexible enough that when they are coming nearer to each other, they must be flexible enough to form the entanglement. Otherwise, if they are not flexible enough, the entanglement is not possible. Okay, you can imagine this thing, that entanglement is possible only when these are flexible enough. So as the cross-linking of water-soluble polymer increases, the mobility of the polymer chains and hence the diffusion and interpenetration of polymer chain decreases. So the flexibility and the cross-link density both are very important factor with respect to the polymer. The concentration is another factor for solid biodiesel drug system. More is the polymer concentration, higher is the mucoadhesive strength until a critical concentration. Remember, this optimum concentration is required. You can't go beyond a particular limit. High concentration may result in coiling of polymer molecules and hence reduced flexibility will be there of the polymer chain in liquid mucoadhesive drug system. So you will have to give due concentration to the concentration in which you are using the polymer for developing the mucoadhesive drug delivery system. Ionization. Mucoadhesivity of polymer containing ionizable groups are affected by the pH of the surrounding media, as in other cases also. So you must take care of the microenvironments ionization status of that polymer. Okay. Now moving to the environmental factors, that microenvironment I am talking about, that pH, the mucoadhesion of polyacrylic acid is favored when the majority of the carboxylate groups are in the unionized form, which occurs at pH below the pK. Surface charge on mucus varies with the pH, and surface charge on polymer affects the degree of hydration with change in pH. So pH, the properties which change with the pH must be taken care of with respect to the polymers. Okay. Swelling characteristic, higher the swelling, higher will be the mucoadhesion in general. Okay. And it allows easy dislodgement after the complete drug release from Mdds. So swelling is a desired property. Initial contact time, the strength of adhesion has been found to change with the initial length of contact time. So if your contact time initial length is there, or determine the extent of swelling and interpenetration of the polymer chain in other than GIT. While in case of initial pressure applied at the contact time, because you need some initial pressure to form the initial contact. So strength of adhesion has been found to change with the initial consolidation force applied to the joint. The depth of interpenetration is affected with this pressure, because lighter will be pressure, the depth will be less. Okay. Now moving to the physiological factors. What are these physiological factors? Number one is effective area. Greater the area exposed, higher will be the adhesion. Simple. While in case of thickness, effective diffusional path length. Greater the thickness, lower will be the flux across the mucosa. Because if mucosa is very thick there, then the flux will be less, because it has to pass across that greater thickness. Composition, mucin turnover and structure of mucosa has got very crucial role. Mucoadhesion and the bioavailability varies with different types of mucosa. Pathological status, if we say that various diseases may alter the physiological conditions of the mucosa, physicochemical properties of mucus. So the overall absorption and bioavailability across the transmucosal route may be affected adversely. Now moving to the drug related factors. If we say this, solubility is the first factor, that it affects the chemical potential gradient, which is driving force for the transmucosal delivery. Partitioning into the superficial layer of epithelium, partition coefficient and extent of absorption forms the Mdds, the mucoadhesive drug system. They are correlated. Diffusivity, higher the diffusivity is a very important factor for the drug. Higher the diffusion coefficient of the drug, greater will be the absorption. So the diffusion criteria, the diffusivity is another important criteria. Ionization. As far as the drug is concerned, the ionization fraction at a pH also governs the mucoadhesion and the absorption from the site. Generally, higher the ionization at a pH, lower will be the absorption from the site. Okay, because the unionized form is more absorbed in general, as we know. Now moving to the molecular size and molecular weight of the drug. Generally, higher the molecular weight, lower will be the diffusivity. So you can't take a very high molecular weight drug for the transmucosal delivery. Small hydrophilic molecules like ranging from 75 to 100 Dalton, they cross oral mucosa rapidly and very easily. So molecular size and weight had got its important in the transmucosal drug delivery. Now moving to the biopharmaceutical factors. Organoleptic properties. Number one, it is important for oral mucosal drug delivery. Bad taste and texture may affect the patient compliance and acceptability, as we know very well. Daily dose size. Dose size must not be too high because in general Mdds are small and they cover only small surface area. So we cannot load a very big amount of the doses into the Mdds. For oral mucosal delivery, the dose requirement is less than 100 mg. You can't load more than 100 mg in general. As far as the biological half-life is concerned, short half-life around 3 to 4 hours are suitable. We cannot take too short drugs with too short biological life of too long biological half-life in both the cases, as we discussed in the TDDs also, transdermal drug delivery. Okay, drugs with very short half-lives are not feasible for MDDs, as we discussed. That if you want to develop the system which are having short biological half-life of 5 minutes, 10 minutes, then it won't be practicable. Toxicity in mucosa. Drugs and polymers which are toxic to a mucosa can't be delivered, or which are irritant to some mucosa can't be delivered through the transmucosal route. Now, these are some of the references we have picked for you. You can go through these references and cover up and prepare this mucoadhesive drug delivery system from these references. Now let me summarize this aspect. In the initial aspect we discussed that what are the what we call mucoadhesive drug delivery systems. There is a substrate, okay, that's a mucous substrate, original biological substrate, and one is the your system. When the adhesion occurs, it is called bioadhesion or mucoadhesion. It can be in general, there are two steps: contact and consolidation stage. Okay, we can, as far as the advantages are concerned and limitations are concerned, advantages, we can circumvent the first pass metabolism, we can improve bioavailability, low doses requirement, and the drugs which are degraded in the GIT can be delivered effectively. But the limitations that you can't deliver the drugs which are having the very short biological half, a very long biological half-life, or you can say which are irritant to mucosa. We can't deliver the drugs. Okay. So as far as the mucoadhesion theories are concerned, we discussed 6 theories. Please remember these theories and uh, try, if separate question is asked for the theories of mucoadhesion, what you have to do, you have to write in the sentences rather than the tabular form which we have discussed. Tabular form is for your quick representation, quick recall of the things. What you have to do for each and every theory, you will have to put the figure explaining that theory. With the for the interest in the interest of time, we have skipped that detailing each and every theory. Otherwise, you should detail each and every theory if there is an exclusive question on theories of mucoadhesion or theories of bioadhesion. Okay. So whether it may be diffusion theory, fracture theory, mechanical theory, electronic theory, wetting theory, diffusion theory, you please remember them by heart, okay, and represent them effectively. And most of the time they are asked. Now, factors affecting mucoadhesion, we have discussed that various factors are there, that the factors related to the polymer, that mucoadhesive polymers. The higher the molecular weight, higher will be the mucoadhesion. Flexible polymer chain length, flexibility, cross-linking density, okay, is size, concentration. We discuss all these things. And viscosity is also another factor, that higher the viscosity in general, for a standard concentration, generally high viscosity grades are preferred for mucoadhesive properties. Then we discuss the environmental related factors, and apart from that, physiological conditions and pathophysiological conditions, because the mucin turnover and physicochemical properties of mucus may change depending on the physiological or pathophysiological conditions. Okay, so please learn these things. The factors are affected, especially in the PG examination points. If we are talking about the MPharm students, these factors are of very much importance for you. You must learn each and every factor and elaborate them with suitable examples of each category. Say for example, I am saying that molecular weight factor, then carbol 972 is mucoadhesive than the carbol 934, isn't it? So in viscosity grade, sodium CMC high viscosity is more mucoadhesive than the sodium CMC low viscosity. So you can give and add on examples on each and every factor. Okay, this is the key of covering the mucoadhesive drug delivery system. We will be discussing the basic aspect, another aspect of mucoadhesive drug delivery system, that what are the classification of these systems, how they can prepare, and how they can be characterized in our next lecture of this series, in the next part. So far from this part, as far as this lecture is concerned, we are done with it. Hope you will remember these factors and theories and the definition of this mucoadhesive drug delivery system, which is providing the drug not only for the local delivery, also for the systemic delivery. Remember this thing. Happy learning from our side. Keep learning and stay tuned for our lectures on drug delivery system. We will be coming back with the next part of this transmucosal or mucoadhesive drug delivery system. Thank you. Thank you for being with us. Happy learning.